Okay. Has anybody viewed a calculus video other than Stuart? Oh, yesterday. Okay. All right. So that was somewhat helpful. Okay. All right. Well, pre-calculus said that a few of them have actually gone to view them. So I guess I might not be making the class hard enough. If I made it harder, then maybe you'd have to go view the videos, right? So if I make it harder, then that might increase the number of people that view my videos. I might get paid more. Okay, good point. Exactly. I think that's what I'll do. Okay, let's try this out. Let's get started. Let's see where you guys are at. I do not write out the four pieces every time. When I get to a complicated enough problem, I definitely do. So I'm going to start writing them out for you just as this. I always write f of u and u of x, and then I write f prime of u and u prime of x. So the first four problems that we do today are going to be like yesterday. They're going to be pretty straightforward and not too difficult. Can somebody tell me what f of u is in this situation? 2u to the sixth. And u of x? 3x minus 5. Sometimes people have difficulty identifying what the inside function is and what the outside function is. So if you have trouble, then I'll start with the inside. The derivative of 3x minus 5 is 3, and the derivative of f prime of u would be 12u. So 12u to the fifth. So what you have to make sure that you do, though, is you plug the 3x minus 5 back in for the u. And so the derivative here, f prime of x, which I will write, is equal to 36u to the fifth, which is the same as 36 times 3x minus 5 to the fifth power. Even Sean will see that some of the problems that we encounter down below that we will have to show a little work here or there. Well, hello. It's so good to see you, Miss Ciota. I think I dropped a sheet off for you, so sure you were. Okay. Let's look at one that I didn't give you yesterday. What if we have a cubed root? What are you going to do now? 7 minus 4x to the 1/3 power. Let us use the rule of Sean Laurie, we will call it. We'll see if you guys understand it. Okay? Start with this. Realize that what happens here, the nature of the chain rule is this. F of u of x, if we were to find the derivative of that, it's equal to f prime of u times u prime of x. So the quick way to think about that is this. The derivative of the inside times the derivative of the outside with the inside left alone. So watch Sean Laurie's method, see if you guys like it. What's the derivative of the inside? -4 times, what's the derivative of the outside? 1/3 u to the, and what is u? So that's kind of what Sean Laurie does. Okay? Derivative of the inside times the derivative of the outside with the inside left alone. I'm just going to do that once just so you guys can kind of see that that's how Sean is thinking of it, but you sure don't have to do it like that. We should write this in better form. We could write it as -4 on top, and on bottom you would have a 3, and you would have the cubed root of that squared. So that would be that derivative. -4 is the derivative of the inside. I'll work this all out. Please note that if you have something in the denominator, you then make it to the negative power. So here we have 5 in the denominator, so we have it to the negative 5th. Boys and girls, please. You have f of u, which would be negative 10 u to the negative 5th. And we have u of x, which is what? Two x minus 3x squared. I derive each f prime of u would be what? What's the derivative of that? 50u to the negative 6th. And u prime of x would be 2 minus 6x. So again, your derivative, you take these two, multiplied each other, insert u back in. 2 minus 6x times 50 times 2x minus 3x squared, all to the negative 6th. These two pieces can go on top. This piece needs to go onto the bottom. And there's our derivative. Again, notice the complexity of the problem. That, forget about the formal definition. Let's say we were just to go back to the same old power rule, and we were to, well, we couldn't even do that to a negative power, but even the first one to the 6th power, if we were to multiply that out 6 times, FOIL it out 6 times, it would take forever. We don't have to do all that. We can simply use our chain rule, and we can get it done. Okay, and the last one. We have, what is u of x in this situation? U of x is 2x to 5th. Ashley, what is f of u? Okay, and so now I derive both f prime of u and u prime of x. What's u prime of x? 10x. What's the derivative of 10x to the 4th? What's the derivative of negative 4 secant of u? Yep, derivative of secant is secant tangent. So we're going to have negative 4 secant of u, tangent of u. Notice we have two u's in this situation, so we need to plug it into both pieces. The negative 4 stays there. It's going to be a constant that multiplies along with the 10. So I have a negative 40 x to the 4th secant of 2x to the 5th tangent of 2x to the 5th. An extremely, extremely involved derivative without the chain rule. Any idea why they call it the chain rule? They do link together. If you think of a pulley, anybody ever seen a pulley where you have one big spindle and you have one little one and the chain pulls them together? One's moving at one rate, the other one's moving at a different rate. Notice you have two functions, okay? This one's moving at a certain rate, and then this one's moving at a certain rate. So if you think of two gears working together and a chain holding those gears together, that's why they call it the chain rule. You have these gears that are intertwined, and they move at different rates, producing an interesting function in the end. Okay, that was child's play, right? We're all good there. Let's get to something that will challenge our brains a little bit more. If you notice, it says find the derivative of the following. You may need to use more than one rule. Now, this is where I'm going to encourage my good friend Sean to make sure that he keeps things a little bit organized here, okay? This would be good. And if he doesn't want to, that's absolutely fine. I definitely have my own way of doing things. So however you want to work is fine, but this is my suggestion to you. First, we identify the rules. Look at this. Negative 3x squared times the cosine of 4x. What rules do I use? This one is the chain rule. This one is product. Chain rule will be the composition of a function. If there is a function that lies within what would normally be x for another function, then you got to use it. So being we have the cosine of a function, therefore we have to use it. What? No, that's a good question. I don't know if I really have a good response right now. Well, we'll try. So I'm gonna, being the product rule sits on the outer part, I'm gonna start with that first, okay? And the product rule says I take the derivative of the first times the second left alone, right? So watch what I do here. I will say f prime of x is equal to, what's the derivative of that? Negative 6x times the second left alone. So cosine of 4x plus negative 3x squared times the derivative of cosine of 4x, right? So before I put that in, okay, before I put that in, you need to derive that using the chain rule. And well, because it's the derivative of that involves the chain rule. You have a 4x on the inside of the cosine. So now we simply just need to come up with that derivative. And I could name the function something else instead of f. I could say, all right, we'll say that g of x is equal to cosine of 4x. And I'll set it up. I'll say g of u, I will say u of x. G prime of u, and u prime of x. And the better that you get at this, the less work you'll probably end up having to write down. But just for notation's sake, I renamed it so I wouldn't get confused with the f up there. But what is g of u? Cosine of u. What is u of x? 4x. What is g prime of u? Negative sine of u. And u prime of x? 4. How do I come up with the entire derivative then? Negative sine of 4x, I plug the u back in. So that's what goes here. So times negative 4 sine of 4x. So I guess really my derivative is negative 6x cosine of 4x plus 12x squared sine of 4x. So technically that would be the derivative then. Is there a question on that problem? Should I, once again, let's just review where we headed. We said this is a product rule. Derivative of the first times the second left alone plus the first left alone times the derivative of the second. And so we found the derivative of that second using the chain rule. Yeah? Okay, let's try another one. Okay. B is tough. It's really tough. What do we see there? What two things do you see? quotient rule and the chain rule. Notice that notice notice I have an inside here, okay? I have an inside piece here, this 2 minus x over 2x plus 3. That's an inside to the outside piece. So if you were to write this as 2 minus x over 2x plus 3 all to the 1/2 power, notice you have a function sitting on the inside of a larger function. And to find the derivative of that inside one, I will need to use the quotient rule. So I have the chain rule and I have the quotient rule. Now, the first one that I need to start out with in this situation is going to be the chain rule. So I will lay it out as such. The reason why I start with the quotient or the chain rule here first is because if you notice the quotient rule sits on the inside of it. And so I've got to use the chain rule first to organize this. And this shouldn't come super intuitively to you right away. This is a hard problem, and you should have to, kind of digest it for a day or two. So let's look at it first. If I wrote this in terms of u, this would be u to the what power? So we have u to the 1/2. That was easy. What is u of x? Yeah, 2 minus x over 2x plus 3. That's that. So then f prime of u would be 1/2 u to the negative 1/2. And u prime of x, what would I have to use? The quotient rule. So if you want to find the derivative of this, now you got to go grab the quotient rule and use it. What does the quotient rule say? Derivative of the top, which is negative 1 times the bottom left alone minus the derivative of the bottom, which is 2 times the top left alone, which is 2 minus x all over the bottom quantity squared. So it looks like I should sort out the top here, shouldn't I? The top, it looks like I have a negative 2x, a minus 3, a minus 4, and a plus 2x. Does that look about right on top there? Over 2x plus 3, quantity squared. What happens? 2x's cancel. I'm left with negative 7 over 2x plus 3, that quantity squared. So that's the derivative of u. So remember, what I want to do is I take f prime of u, multiply it by u prime of x, and I need to substitute u back in. So I'm going to write that out. 1/2 u to the negative 1/2, so 2 minus x over 2x plus 3 to the negative 1/2. Right? Times 7 over 2x plus 3, that quantity squared. Sorry, negative 7. Now, will you promise not to hate me? Okay. Well, no, just remember, okay, this is a really good thing. What happens when you have a negative exponent? What can you do? We can flip-flop, right? Yes. No, that was fine. Yeah, no. So, in this case, because I have a because I have a rational expression with something at top and bottom, it's going to make it easier to flip. So what we're going to have is we're going to have the square root of this on top, right? All of that on top. What do I have on bottom? 2 times the square root of 2 minus x times 2x plus 3 quantity squared. Yeah, it's the 1/2 is distributed top and the bottom. Well, just because, you know, like if you have 5/4 and a quantity squared, that's going to be 25 over 16. You know, uh, but there is one small little piece left. See the 2x plus the 3? See the 2x plus the 3? Those are, you know, common bases. It would kind of be like if you had x to the 1/2 over x squared, right? What can you do to your exponents? You can subtract them and get 3/2 in the denominator, right? Yeah. So, yeah, so what you really want here is -7 over 2 square roots of 2 minus x times 2x plus 3 to the 3/2 power. That would be sufficient. How about this? Can I give you guys 5 minutes to let's put C aside. Let's see if you could do. Oh no. We'll do C and D tomorrow, but let's look at some easier stuff on the backside. So I think that kind of. So, let's say we're not given the function, but we're given some information. It says, "Oh, raise your hand if you're not here tomorrow." What? All right. Party for everybody that's here. Okay, we'll figure something out. You, but you know, really, with those two examples, you've learned a lot of what you need to know for that assignment. Here we just finished them off, but let's try an example that's a little bit easier. But here you're not actually given the function. It says suppose that f of x is a composition of f of g of x, and that f of 3 is 2, g of 3 is -1, f prime of -1 is 1, and g prime of 3 is 4. You want to find f prime of 3. Well, you guys tell me. If f of x is equal to f of g of x, that's a composition function, right? Then what is the derivative of that equal to? How do I take the derivative of that? What do I do? The chain rule. So that's the derivative of the, so g prime of x times f prime of g of x. So that's what I need. Not too bad. What's this? What's g prime of x? We want to find it at 3, so g prime of 3 is 4. Times what is g of 3? -1. So what this is really asking is what is f prime. You guys all said that g of x or g of 3 is -1, right? So what this is really asking is what is f prime of -1? What is f prime of -1? 1. How do you like them apples? So not too bad. Just got to write it out. And let's try one more. Now instead of giving the values, now it gives us a graph. And it says, given the following graphs, u of x is f of g of x, and then w of x is g of f of x. Find u prime of 1 and w prime of negative 2. You can do it. You can do it. You can do it. Yeah. So we're going to start with this guy right here. U prime of x. U prime of x is equal to what? If I want to derive this, what is it? G prime of x. Very good. Well, remember that the chain rule says that it's f prime of u times u prime of x. So that's what the chain rule says. So this is the derivative of the inside, which is g prime of x. And then this is the derivative of the outside with the inside inserted back in. Good question, Morgan. So we can do this. We're wondering u prime of 1, right? So we got to find 1. Well, let's find g prime at 1. Well, we look at 1 right here. Ashley Tavis, how do you know it's 3? The slope. Ashley is saying, what is the slope? What is the rate of the change of the function at x equals 1? And she says that the slope of that line is 3. Excellent. Now, what is the actual value of g of 1? 2. So I'm really wondering what is f prime of 2. So I go to 2, and I'm wondering what f prime is there. The slope is negative 2. So if you do u prime of 1, you get 3 times negative 2 is negative 6. Okay, okay, so we actually found g of 1. And when we found g of 1, so we looked at 1, we went up, and we said, oh, g's at 2 up there. You try the next one on your own. You try, so now you're going to do g of f of x. Try g of f of x. Yeah. Yeah, so like this one would be w prime of x is going to be the derivative of the inside, which is f prime of x, times g prime of f of x. So w of x is identified to be the composition of those two. So here you're gonna use this, and you want to use the value of negative 2. So you want to use the value of negative 2. So see if you can get negative 2 to work out there. I'll slowly work it out behind you guys and see where we get. Stuart, I'm gonna put you on pause here. Okay. I got mixed up here. I kept on mixing up g and f of x. Sorry. So that's kind of tough. That's kind of confusing. Who wrote that problem? So if we think about it, f prime of negative 2, I look at negative 2, and it looks like this blue one right here. Hey, don't move. It looks like this blue one is f. So that's going to help me out here as I draw this out. And then this one's g. So f prime of negative 2 looks like the slope is 1. Slope of that guy is 1, which is right there. And then I do this piece, so I got to find f of negative 2. And if you go here, f of negative 2 is 5. So I really want to know what g prime of 5 is. So I go to 5, and the slope right there looks like it's 1/4. So 1/4. So 1 times 1/4 is 1/4. Raise your hand if you got it. Whoa! All right, nice job. Okay, let's put it away.